So hi, my name is Arun Gupta, and I work for Red Hat. This is my second week at Red Hat. I've been with Oracle for a long time, 14 years almost, 14 plus years actually. I joined Red Hat as a director of developer advocacy. So my goal at Red Hat is to basically reach out to developers like you, speak at different events like this, and I'm responsible for entire JBoss middleware portfolio. So not just the Wildfly, which is their application server, but also their commercial product. I'm responsible for developer outreach for all of that. I work very closely with Ray Plosky, who some of you may know, and he's my peer. We both of us work together hand in hand to make this thing possible for Red Hat. So today, well, depending upon how much time we have, generally you don't ask me that question because I can talk for hours. I've written a book on it, so I can talk for days also. But given the time that we have, my goal is to kind of show you enough so that you get started with it, and then give you enough data points that you understand what the basic technology is, what the use cases are, and go from there. Okay? Anything and everything that I'm showing today is already available on my GitHub repo. So let's start with that first. So this is my GitHub repo. Arun-Gupta, that's sort of what my GitHub repo is. Java E7-samples is where all the samples are available. On this repo, there are about 170 odd samples, all brand new, focused exclusively on Java E7 technologies. So there are tons of samples over here. For example, if you want to look at all the WebSocket samples, so you click on WebSocket here, and then you look at it. There are about 30 plus samples just on WebSocket. That's how I understand the technology. That's how I learn the technology. There is no better way. You can read the spec, you can write some tests, but there is no better way of learning the technology unless the rubber meets the road. So if you want to learn about JAX-RS, for example, you can click on JaX-RS directory here, and there are about 25 odd samples just for JAX-RS. Each sample is very conventional. It starts with a JSP and a servlet because that's the easiest way to drive it. But essentially, that's not the focus. The focus is really what the underlying background is. When you are searching, how many times you go to Alta Vista, Yahoo, or Google? You go to Google. How many go to Google? Pretty much everybody goes to Google. What matters is the simple interface over there and the effective backend of it. And that's my thought process. JSP servlet are very simple to begin with. You don't have to really put a rocket science behind it. But you're interested in the crux of the sample. Hey, I want to understand WebSocket. So that's fine. Let's keep a basic line that JSP servlet is a basic line for all the samples, all 170, all of them pretty much have the same basic starting point, unless it's JSF, where we have switched gears. But for all the samples, JSP servlet is a starting point, and then I'm showing, this is how my CDI looks like. This is how my WebSocket looks like. This is how my servlet looks like. This is how my JAX-RS looks like. So you understand that's sort of the thought process that we're going with. They're all Maven-driven samples. So nothing really about IDE, but I personally like the Maven support in NetBeans IDE the best. And that's what I'm going to use NetBeans. The problem with NetBeans is it does not support Wildfly, which is sort of the app server of my choice now. All these samples run very well on GlassFish though. So if you choose the combination of NetBeans and GlassFish, all these samples would run fine because that's how exactly I built these samples. I've been running several of these actually on Wildfly now, and there are some issues which work, which don't work, but because Wildfly is not yet Java E7 compliant. And I will make sure that it is Java E7 compliant. That's my role. All right, so let's start with a simple WebSocket sample first. So no pun intended, let's shut down GlassFish here and let's start up Wildfly here. Change window and start up Wildfly. Now, Wildfly is what you guys used to know as JBoss application server. Earlier this year, JBoss community is huge. They decided, application server has its own identity. So they said, let's give it its own name. Let it have its own life cycle, etc. It's still a deliverable from the JBoss community, but Wildfly is the application server component of it. So now, I got tons of samples deployed on this particular Wildfly, as you can see. And all those samples are loading up. But anyway, once the server is up, So let me show you a sample. Any of you were in my Java E7 talk, WebSocket talk? Couple of you. Okay, so you will find this particular samples are same because I've shown this in my earlier talk, but since most of you were not there, I'll repeat the sample. So this is one URL, and this is another URL, okay? So what I have is a HTML5 canvas here. Both of these browsers are listening to a WebSocket endpoint, which is running on Wildfly. So this is running on Wildfly right now. If I click anywhere in the canvas, the same red square is replicated on the other browser. If I change the color, same thing is replicated here. Now if I go back in this browser, I change the color and the shape, and I click here, this thing gets reflected in the other browser as well. So it's a full duplex, two-way, bi-directional communication basically between the two browsers. Now, let's say one of the browsers goes offline. I mean, this browsers could potentially be across the internet on two different machines, two different operating systems, even a mobile, iPad, or whatever it is, right? So, but if it goes offline, it's just clicking around, nothing is happening here. And when the browser does come online, say you get network connectivity back, but now the games are out of sync effectively. So how do you bring them back in sync? You click on this button, snapshot, and the browsers are synced right away. Okay? So that's sort of the use case. Now, how does this work? Typically, in a HTTP environment, you will do that dirty polling, long polling mechanism, and figure out, oh, there is some data available at the server, let me pull it, or let me do long polling. So keep a connection open and it's sitting idle until data is available and things like that. But those are essentially hacks. And you have to tune them for your server application, specific to your application. That's exactly where WebSockets are handy. WebSockets gives you a standard bi-directional full duplex communication channel. Bi-directional means client to server, server to client. Full duplex means they can both send message to each other independent of each other. There is no predefined request-response design pattern. They can send message to each other independent of each other, and the best part being over a single TCP connection. So what's happening here is, well, before that, WebSockets can send text data and binary data. Okay, that's another important facet of WebSocket. So what's happening here is, when I click anywhere in the HTML5 canvas here, it captures the shape, the color, the X, and the Y coordinate. It captures those four aspects, puts it into a JSON structure, send it over the wire as a JSON text. The server endpoint that is listening to that WebSocket gets the data, and it knows what all clients are connected to it, and broadcasts it back to all the clients. The clients, when they get the same JSON data, for example, this guy here, it just say, hey, I know the X and Y and the shape and the color, and it refreshes itself. So that's sort of the thought process. It's a true hub and spoke model, where the server is the hub, and the clients are at the spoke, at the end of the spoke. They send a message to the hub, and then it broadcasts it to all of them across all the spokes. Okay? So let's see how that is being implemented in Java for us. First of all, this is my whiteboard endpoint. This is a Pojo class. Here, I want to make it a server endpoint, then I put the add server endpoint annotation there. I'm specifying the URI at which the endpoint is listening. Okay. Now, as I said, every time I'm sending the JSON text, so you could either deal with the JSON text in your business logic and play around with it and say, I'm going to make sense out of the JSON text and then process it and then send it back. Or you could say, I don't care about the JSON, whatever on the wire format is, give me a business domain object and I'm going to deal with that and I'll play around with that. And that's what the figure encoder and decoder gives you. What it's saying basically is, there are figure encoder and decoder class which understands how to encode JSON text to your business domain object. So now if I look at, for example, figure decoder, it says, hey, you know what, I'm a text decoder, I'm going to give you a figure, in turn, I'm going to take a string, convert it into JSON using my JSON API, and I'm going to return a figure. So this is a standard interface. Now you implement it, you implement those methods, and you got the ability to convert string data into text. Similarly, I have encoder, which says I'm going to take a figure and convert it back to string, because eventually on the wire for a WebSocket, what goes is string or binary. That's what you want to deal with. But in the business method, you want to deal with your business object. So you're dealing with figure in your business logic, and the encoder decoder takes care of converting to and from string for you. Now in on-open and on-close, those are my two additional methods. I've added two annotations called as add on-close and add on-open. The idea is these are my lifecycle callbacks. So it's saying every time there is a connection being opened or closed, do this or invoke this business method. In this case, for example, I have a set of session here. Session is the encapsulation of the client that is making a connection. So I'm just adding it to the list and removing it from the list. At a given point, I have the list of active clients that are connected to this particular server. Then I have a broadcast figure method. In that, because figure can be encoded or decoded by a text encoder and decoder, every time a text message is being received by the WebSocket endpoint, this method is automatically being dispatched. The name of the method doesn't matter. What matters is the annotation. And then I'm getting a encapsulation of the client that is sending the message. So figure is where my JSON text is being converted into figure and given to me. And in the loop on line 77 here, all I'm doing is going through the loop and broadcasting it to all the clients. So whether it's 1, 2, or n number of clients, it's just broadcasting it. Similarly, line 85, if I go here, when I click on snapshot, at that point it says, you know what, I don't know what all you have changed. I'm going to take a picture of this snapshot, convert it into an array buffer, send it as a byte array, or array buffer, which is a native JavaScript binary array. I'm going to send it as a binary data over the wire, which goes as a WebSocket frame. That data you have accessible on the server side in byte buffer, could be a byte array as well. And I'm not processing this data at all, I'm just raw pushing it back to all the clients, which as soon as they receive the data, they refresh themselves. So very simple, very clean, very intuitive programming model for Java EE 7. On the JavaScript side, which is where my client side is working, when I want to connect with the WebSocket endpoint, I start with an HTTP connection, but then I upgrade to a WebSocket connection. An HTTP upgrade is a standard mechanism that is being defined in the HTTP specification, which says, hey, you can have a HTTP connection, but that could be upgraded using standard HTTP headers to a non-HTTP protocol. The idea was use it for HTTP 1.0 to 1.1, 1.1 to 2.0, things like that. But WebSocket has leveraged the same mechanism and is using that to upgrade the protocol. So, first of all, you connect to ws://URI scheme. This new WebSocket is a W3C JavaScript API. The moment you specify that API, that means that's when it's connecting to the WebSocket endpoint. That's when it's, and in that you specify the URI. So that's when the moment you say WebSocket URI on this line is saying, you know what, I want to connect to a WebSocket endpoint, let's upgrade the existing HTTP connection to a WebSocket. And everything else is standard JavaScript. You know, I have callback handlers, what happens when I receive a binary message, what happens when I receive a text message, how do I send a message. So for example, I want to send a text message, no problem. Take a JSON, send it as this. You want to send a binary message, exact same overloaded method, it's different semantic over here. Syntax is exactly the same. Okay? So that's sort of a quick overview of how WebSockets look like in Java EE 7. Another new technology that has been added to Java EE 7 is where how you can build batch applications in a standard way. So Spring Batch, yes, has worked very well so far, but it's still proprietary third party. You have to bundle that old gobbledygook that comes along with it. You're bundling a runtime with your war file, deploying on a different runtime without leveraging the server runtime. Kind of very counterintuitive to me. I'm not a big Spring boy anyway. So coming to the point, that proprietary technology has served well in the interim till Java EE was catching up. Now that Java EE 7 supports standard batch programming, it's time to get your act together, right? So this is how we're going to build. I'm going to show you a simple sample application, very typical sample application. Think about a sales organization, for example. But think of the movieplex. Now you're running a 7-theater movieplex. At the end of the day, you get the sales from all the 7 cineplexes, and they're sending you the data in the form of a CSV. So you want to read those CSV. At the end of the day, you calculate the sales, do some processing, generate some more records, and put it into the database and dump the CSV somewhere else, or maybe the archive the CSVs. Now, the number of records could be huge. The number of records going depending upon what kind of movies are you running, how big the theater are, they could be complex. Let's say we're dealing with, say, thousands of records. So what you want to do in that case is you may want to read, open up a CSV file, read a record, validate it, process it basically, and give it to a database for writing. You may not want to write it right away, because for every read, if you do the write, that's going to be a costly operation. So what you want to do is read, process, and aggregate. Read, process, and aggregate. And once you have done aggregation of, say, 10 items together, then you will say, now go write it into the database altogether. Because think about it. For every read, you may not be doing the write. For some reads, data may be invalid, and you may sort of reject the record and don't aggregate anything. So maybe you're doing 10 reads and just 9 writes, for example, 9 aggregated writes. And that is basically done in one transaction. Now that processing style in batch is called as chunk, and is the primary and the preferred processing style. So what we have is a reader, a processor, and a writer. And in addition, what we also define is the item count, or the chunk item count, which says, how many records you're going to read, process, give it for aggregation, and then write. Now a chunk, or in general, job is defined using a job specification language, which is defined in Java EE 7 using job XML, because it's XML language. So let me show you the entry point of my job specification language here. So here I have my job, which has a logical ID, a namespace, version, etc. This job has one single step, but it could definitely have a lot more steps, but this one has a single step. This job has one chunk, and a job has a step, and step has one chunk. A step can be either a chunk or a batchlet. Batchlet is the other processing. What did I do? Other processing style? No, I didn't do anything. Okay. Okay. So a job has a step. Step has a chunk. It could be a chunk or a batchlet. Batchlet is the other processing style, but it's not the preferred processing style. We'll not talk about that instead. So in this step, what's that? Okay. Sitting correctly? I'm not moving my head today. Okay. Let's try this again. In this step, I have a chunk. In the chunk, I'm defining what my item count is. So I'm saying I'm going to read, process 3 items, and give it for aggregation. And what I'm defining is what my reader, processor, and writers are. Okay. If I look at my item reader, for example, in my item reader, I'm opening the CSV file. In this case, my CSV file happens to be bundled in the WAR file, so I can just open it as is. Originally, I could read it from a URL, could be from a file system, all those things can happen. And then I have a read item method where I'm just dumb reading the item. Again, dumb reading, there is no processing happening here. It's a true separation of concerns design pattern. So I'm just reading the item here. In the processor, I could say it's just implementing an item processor, and there's just one method called as process item. So the item that we just read, which was basically a string, is available to me as a parameter here. I can do the validation on the item. And here I'm doing strict checking of date, for example. If it's a date of birth or date of joining or whatever that date is, I'm doing a processing on that. If it's a valid object, I return a new person. Person being a JPA entity. Okay. It's just a JPA entity for me. So right here you can see there's an entity annotation right here. And if it's not valid, I'm returning null. What that means is, okay, it's not a good record, return null. That means don't give it for aggregation. And finally, I have item writer in that I have write items where I've already injected entity manager, and all I'm doing is through the list, I'm going through the items and persisting it to the database. Now, the beauty of all this is once you have your job XML defined, for each chunk that is automatically run within a transaction, and this is a container managed transaction. So the container automatically starts the transaction before the read process write aggregate write cycle happens, and after the write has happened, it commits the transaction. So all of that one chunk of 3 is done in a container managed transaction. A new transaction is automatically started for you by the container. And the other important part is, say if you're reading thousands of records, there are a million records, just to keep it simple. If you've read 500,000 records and your item count is say 100. Now what if you are reading the next 100th record and your job fails? That doesn't mean that everything is lost, because first of all, the transaction is committed. Like if you read the last 100 record in the 500,000, that transaction is committed into the database. Second is there are inherent checkpointing mechanism, so that when you're reading say the 57th record in that 100, and if the job fails, it's not going to go back to 0. It's going to go back to the first record after 500,000. So that all that commit is good, but the job is also starting at the right place where the last checkpointing was done. All of that is good to know, but that happens automatically for you. That's done by the runtime. And finally, what we have here is how we kickstart the job. Effectively, what I'm saying is, I have a batch runtime, that's a JavaX class. Give me a job operator, the job operator knows where the jobs are existing. Well, the job is basically my myjob.xml. So this is myjob.xml, whatever the file name is, you give the file name here, and you trigger the job. That's it. It's as simple as starting the job. Typical question is, how do I schedule this task? Well, in EJB we have an add schedule annotation. So you put this method in an EJB add schedule, basically. You have EJB method in which you put an add schedule, which is where you specify your cron syntax, which will trigger like 2 a.m. Saturday morning or 2 a.m. Sunday morning, and that's where you can put these 2 methods automatically, and that will work. Okay? So, or you can use a quartz timer if you want to do it that way. All of that is very much possible. Okay? That's some of the variations. Another question typically people ask is, do I have to go the XML way? Yes, that is the only way by which you can describe a job. There is no other DSL or Java-specific DSL by which you can describe the job, because a lot of this work actually came from VMware or Spring Source. So there was no point reinventing the wheel, but a lot of people are comfortable with this. Now, a future version of the spec may look at that, but we don't know yet. By the way, the WebSocket sample that I was running on Wildfly. The chunk CSV database sample, this morning I saw a blog, somebody has been able to run that on Wildfly as well, because one of the requirements for the batch runtime is, for example, you need a database. Because the batch runtime needs to create those checkpointing tables, need to maintain that transaction status, all of that in a persistent manner, because that's where it can recover from a failed state, from a failed JVM, etc. So it needs to have a backing database. Now Java E7 runtime requires a database at a runtime. With GlassFish, we bundle with JavaDB. So that's where all the state is being stored. With Wildfly, it's an in-memory HSQL DB where all the state is being stored. So I just couldn't figure out how to configure that in-memory database. But literally this morning, somebody took this sample, used that exact same code, and have been able to run it in Wildfly. So the point being, all the batch samples are running on Wildfly as well. And whatever WebSocket samples I've tried, they work as well. Of course, all the samples, they work on GlassFish very well too. Now the interesting part of a batch job is job XML. Most of the code, the reader, processor, writer, would stay the same. So let me show you another job XML here. So here I have a job XML. It has a single step. The step is of the type chunk. Item count is 3, reader, processor, and writer. The reader, in addition, is also specifying a couple of properties like start and end. So you can inject the property values over there. Where is the value coming from? What I'm saying is, hey, I'm running on a multi-core machine. Can I use my cores so that the job can be run concurrently? Where I can do the reading concurrently and do the processing and the writing concurrently as well? So here what's happening is, declaratively, without changing my code in any sense, I'm saying, I'm defining a partition. The partitions are 2. I'm assuming I'm running on a 2-core machine. And I'm saying partition 0, partition 1, what the start and the end values are. 1 to 10 and 11 to 20. So let's say I have 20 records to read. I'm going to say process first 10 records on one core, next 10 records on the second core. Now what I'm doing here is declarative. You can of course do this programmatically as well, where you can say, you know what, I'm going to specify my partition planner in a program, in a Java program, where I'm dynamically going to figure out how many partitions I need to run on, what my properties are, which is going to be based upon some other aspects of the file or whatever it is. So it gives you a lot more flexibility in that sense on how you're going to define these partitions. That's pretty powerful in my opinion. You can also do sort of a workflow here, wherein you can say, run step A and step B together as a flow, and then do step C and D as another flow. So you can define those flows. You can also define mechanisms by which you can say, if job A failed with such and such status, then trigger job B. So all those samples, by the way, are there in the GitHub repository. So if I want to walk you back here, so you can see there are decision, flow, listeners, split, a whole bunch of different facets that are available, the way you can create workflow easily in your batch applications. Listeners is a particularly interesting one because what you can do is you can define listeners at different layers. At a job layer, at a step layer, at a chunk layer, at a reader layer, pre-reader, post-reader, all of those listeners can be easily configured as well. So it's pretty comprehensive in my opinion for the first release, but of course we can always do a lot better. And I've been following the JSR 352 list, and they're already thinking in terms of some of the changes. Another question people ask is, hey, I'm in the Java EE land, why do I have to say, give me a job operator, or batch runtime, give me a job operator? Why I can't inject the job operator itself? So yes, that is already being worked upon. I filed a bug on that, and I saw some movement on that this morning. So hopefully that will be fixed in the version 1.1, where you should be able to inject the job operator instead of doing an application managed job operator. There will be a container managed job operator. One of the big changes that we did was also in JMS 2.0. And primarily because when JMS 1.1 was done, the Java language was not that modern. I mean, it was literally 10 years ago when we had JDK 1.4. No generics, no dependency injection, no annotations, nothing was available at that point of time. It has changed a lot. And somehow JMS could not get a rev in between. But when we got a rev, the idea was to kind of catch up with the platform, the entire Java platform very well. So what we've done is, in JMS 2.0, there is a classic message receiver and a classic message sender, or a classic API. This classic API is what used to be JMS 1.1 API. JMS 2.0 API is called the simplified API. So I'm going to show you a sample of how a classic API looks like and how a simplified API looks like. This is my very traditional classic message sender, and this, if you have written a JMS code, this will look very familiar. I inject my connection factory, my destination, then I write a lot of boilerplate code, effectively saying, give me a create a connection, start the connection, get a session, get a producer, get a text message. My real intent is this, message producer.send. But then, all of these throw checked exceptions, so throw a checked exception here, and close the connection, which also throws a checked exception. So I don't know, what do I do? Typically, what I've seen is people do throw a new runtime exception, propagate it. I don't care, I don't want to deal with it. Let somebody else deal with it, not my problem. But that's a typical common code. Well, if that's a typical common code, let's adapt it. The other part is, why do we have to write such a big boilerplate code? So, and why do we have to inject all of these objects? So that's some of the feedback that we took for JMS 1.1, and we made it clean. So let's take a look at my simplified message sender now. So that's how my simplified message sender looks like. All I'm doing is inject my JMS context. JMS context is the entry point to the new JMS 2.0 API. I inject the JMS context. My producer, consumer, all of them are encapsulated within JMS context. If I don't specify a connection factory, it uses a default connection factory. That is a requirement per Java EE 7 runtime. So if you are a Java EE 7 compliant container, you have to have a default connection, JMS connection factory. And that's what is meaning over here. Then you're saying, okay, inject a destination. This destination, by the way, is created during my deployment. So right here, on my Pojo app, specify a new JMS destination definition annotation, which is automatically created during application deployment itself. So we inject the same destination here, and the best part, from the context, I create a producer and I send the message to this destination, and this is the message. So really clean API, using a builder pattern. Everything is throwing a runtime exception. Now, if the user code is going to do it, I might as well do it myself. And because you're injecting a JMS context, it's a container managed JMS context. You don't need to close it and things like that. It's, by the way, using auto-closable resources. So if you put it in a try with resources, it will automatically take care of closing it. But because this is container managed, I don't even worry about that. Let the container figure out when to close it, and it will take care of closing it. So I think this is a very valid, very significant change in the Java EE 7 platform, because look at the amount of boilerplate code that has been cut down. So literally from all of this, like 55 to 85, 30 lines here, from 53 to like 60, like half the lines. And by the way, I'm including all the braces and everything else as well, and spaces also. And in addition, I'm also doing the creation of my resource. So literally, it's a 1/3 the code that you have to write in order to just send a message now. The receiving code is similar as well. Another new API that was added as part of the Java EE 7 platform was Java API for JSON processing. So in XML land in Java, we have Java API for XML processing and Java API for XML binding. XML processing is a lower level API where you can deal with how you want to deal with the raw data. I mean, XML data at a raw layer. You get the raw data as a stream, and then you can say, you know what, throw me an event when a start of an element is occurring or end of an element is occurring and things like that. Throw me when an attribute is being encountered. That's called as a stack-based parsing or event-based parsing. And then the other thing in JAX-P is event model, where you can say, you know what, read the entire XML as a DOM, and I'm going to manipulate it myself. Those are the two ways that we do in JAX-P. JSON binding on the other side is you take a Pojo, put an annotation on it, say go figure how you're going to map this to a XML and vice versa. The Java API for JSON processing is more like JAX-P, Java API for XML processing, where you say, you know what, I have a lower level control of JSON. So you have a streaming API and an object model API. Java API for JSON binding, where you can take an object, put an annotation on it. Like today we say add XML element or XML root on a Pojo, and JaxP knows what are the conventions. So ideally it would be nice if you could take a Pojo and say add JSON root or something like that. And then it would know how to convert to JSON binding or JSON data structure, but that's coming later. Java API for JSON processing is focused on the streaming and the object model API. So let me show you how that works. Well, first of all, I create a JSON factory. And now I want to create an empty object. So this is a streaming API, by the way, and I'm generating an object. So what I say is, from the factory, I get a generator. I got a JSON generator. Then I say start object and end object. So start object is curly parenthesis, end object is end curly parenthesis. That's it. That's how you write a simple object. You can see the API is a little verbose. It takes a lot of effort to write a simple JSON structure, but that's what it is. That's sort of the first version of the JSON processing. Now you want to create a simple object, which is write the start object, write a name value, which is apple red, write another name value, banana yellow, and write the end. Now you want to create a simple array. So in an array, you start the array, you start an object, in an object, write an element, end the object, start another object, write another element, and end the object, and then finally end the array. Okay? Let's see how we run this on GlassFish. So I'm gonna go down here, close while fly. Their ports by default are 8080, so they conflict in that sense. So let me run this guy here. NetBeans does provide the best out-of-the-box experience for Java EE 7 development and integration with GlassFish in that sense. So that's what I mean by saying, I'm graphically challenged, but it does the job. Simple JSP servlet, and it's a streaming generator servlet, which is going to say create an empty object. So use it this way, create a simple object with two name value pairs. This is an array with two elements, and this is a little bit of nested structure. So you can get the point. You want to see the API usage rather than getting lost in the fancy UI and things like that. Now, one of the things that was possible and that we have always known about container managed transactions is they're only available in an EJB. You can do user managed transactions wherever you want to do, but if you want container managed transactions, the only way to do that is EJB. With Java EE 7, that is changing. Now you can have container managed transactions outside EJB on a Pojo. So for example, you can take a Pojo, you want to make a method of the Pojo, not all the methods, just one method of the Pojo to be transactional. You can put the add transactional annotation on it. In addition, what we've also introduced is add transaction scoped annotation, which is a new CDI scope. And what that gives you is, for example here, if I specify add transaction scope, it ties the life cycle of the bean to a transaction. That means if a transaction is active, the bean is available. If the transaction is not active, the bean is not available. As simple as that. And that's the way it works. I have just simple method get ID, where I say just this plus string. It's basically giving me the object identifier. Okay. Let's see how we're going to use this in a transactional bean now. So here, this is just a Pojo. There are no annotations on it of the class my transaction bean. And I'm injecting two beans here. Well, trying to inject my bean twice using bean 1 and bean 2. Now the way CDI works, if you inject a bean, it does not inject an instance of the bean right there itself. It injects a proxy to the bean, so that when you request the actual bean, it figures out what the current context in the scope is, and it instantiates the bean if it does not already exist, and then it gives you an instance of the bean at that point of time. So here I have three scenarios. Scenario 1 is I'm saying bean1.getID, bean2.getID. What's going to happen is is going to say, oh, bean 1 and bean 2, you are at transactional, so you are running in a transaction. Let me get the bean instance, which is for bean 1. My bean, so it is instantiates a bean. Bean does not exist. It gets the bean, prints the ID. But the moment you go to bean 2, it says, you're pointing to the same bean, and we're in the same transaction, so I'm not going to instantiate a new bean. I'm going to give you the same bean because you're in the same transaction. So effectively, these two IDs are exactly alike. Now in this case, this is, well, now the thing is, once you get out of the method, the transaction is committed / rollback. By default committed, unless a runtime exception is being thrown. In this case, you are starting a new transaction. So you do the same thing, bean1.getID, bean2.getID. But the point being, this is a new transaction, so the two identifiers printed here are exactly alike, but different from the ones over here. Because it's a new transaction. Because the moment you encounter this line, it says, there is no bean existing in the transaction. Let me instantiate a bean. And then this one again, it says, oh, bean already exists. Let me pack up the same bean to the proxy, and it prints the same identifier. In this case, there is no add transactional. When you try to get the get ID of the bean, it says, oh, you know what, context not active, or basically there is no transactional context, so I cannot give you a bean. Because you still have the proxy available, and that's why it doesn't give you an NPE, it doesn't give you a null pointer here, because the proxy is still accessible. But the moment you try to instantiate the bean or try to get a backing bean, it says, oh, the bean does not exist because it's not in the right context. So this way you can easily get actually a container managed transactions outside of an EJB. One of the focus of JAX-RS, the primary focus of JAX-RS up at 1.1 has been how we can provide a simple server-side annotation which will allow you to publish a POJO as a REST endpoint. And that's the way it works. So here I'm saying public class my resource is published at this and this path. If you access this resource using HTTP GET, call this business method. This business method, even though it's returning person array, it could produce the application XML or application JSON. In addition, you can call this resource using /persons / some random ID. That random ID is mapped to this parameter over here, where you can then instantiate whatever you want, dig into the database, get the real person, and return the person. And this again can return JSON / XML and things like that. So very standard REST syntax. But JAX-RS 1.1 has been focused on server-side annotations. With JAX-RS 2.0, we're adding a brand new client-side API. So you have a standard way of accessing this REST endpoint. So let me show you the before and the after code on if you were to access this sort of a REST endpoint or any REST endpoint using URL connection, which is the java.net way, and then the client API. This is the standard way of doing it using URL connection. So I'm saying, okay, create a new URL, open the URL connection, set the metadata, and the ugly part is if you want to do a post, you have to set do output true. Otherwise, by default, it's get. Then you set some more metadata. Then you do some string concatenation, URL encoder.encode and format and all that stuff. Then you open the output stream, then you open the input stream, you write the output stream, read from the input stream, and you disconnect. It's a very trivial request. I'm just making basically, think about, if you were to write this code in JMS 1.1 and JMS 2.0, you have to comment that code. In JMS 2.0, you just know the code and you read it, what it means. Same thing here. You have to comment it. Well, why am I doing a certain thing? Because the API is not very clear. The Java docs are not very clear. And that's the nature of the API. So if you're sending a simple post request, in this case I cannot get, if you're sending a post request, this is how you need to write the code. Let's see how we do all of this using HTTP or JAX-RS to client API. Client builder is my entry point to the JAX-RS 2 client API. I say, Mr. Client Builder, give me a new client here. On the client, I set a target, which gives me basically, which is the URI of the endpoint that needs to be invoked. And that's going to give me a web target, which is what I'm going to use. Which is what I'm going to use to invoke the endpoint. Now, on the web target, if I want to make a post request, I create a multi-valued hash map. In the multi-valued hash map, I add the name-value pairs. On the target that I got, I build a request and I post an entity form. So it's a very type-safe way. Now, there are strings involved, of course, because those are name-value pairs respectively. But you're using a very fluent builder pattern over here in order to build your request and make post a request to the endpoint, which is then going to process it and return the response back. On this one, you're saying on the target, build a request, get the response, but this time give me the response back as a person array. So what you get back is a person array. There was no data binding in the previous case because you are really dealing with the raw streams over there. So you have to figure out what you're going to do with that stream. How do you want to parse that stream? In this case, for example, I'm saying on the target, I have a variable URI, specified using curly parentheses. Then I'm going to resolve the template, map this ID to 1. I'm saying what I want the data back is application/XML. Get me the data type is still person. These two are sort of counterintuitive because typically if you are specifying your media type, then you don't care about what your return type is. You can do one or the other. It wouldn't make sense to do both of them. Effectively, if you really want your raw XML data, then you would put string.class here, get the data back as string. But if you're getting back a POJO, then you wouldn't specify application XML. So that's a brand new addition to the JAX-RS, in the JAX-RS API. Some other samples that I can talk through is, we've also added support for asynchrony in the client and the server side. The idea is, on the server side, if you know your request processing is going to take a longer, or in general longer, then what you're going to do is do the standard suspend/resume design pattern, but now there is support for that in JAX-RS. So for example, you can say, when my request is coming in, I'm going to suspend the request, spin a new thread, get the job done over there. When the job is done, then I'm going to tell the client back that the job is done and return the response back. So on the server side, effectively, your server thread is free to accept more requests. You are processing in a user thread, basically. And that allows your server to be a lot more scalable because you have more user threads that are spinning and doing the job. In the meanwhile, the client is still synchronous because the server is asynchronous, but the client is still waiting for the response. Now switch it around. Let's say your server is okay, but you want to make your client asynchronous. And that's possible too. So the way we were making calls earlier, so we were saying, for example, get here, okay? So I could say target, build a request, then in between here I could say async.get. Then I'm actually, from the client side, I'm making an async request. Then instead of actually getting a person back, I get a future of person back. Once I get a future, then I can play around with that future. How long is it going to take to process the response? And if I waited too long, go ahead, cancel the response or processing and all those things. Now, client-side asynchrony and server-side asynchrony are completely independent, but they, of course, can work with each other. And in the sense, we could put both of them in your programming model, depending on your scalability requirements. We've also added support for filters and interceptors. Filters and interceptors typically, if you wanna deal with only HTTP header processing, that's the use case for your filters. So for example, you wanna just log the HTTP headers. So go ahead, put a filter right there. Logging filter, auditing filter, name it, whatever filter you wanna put. It's basically implementing an interface and then saying it has access to the HTTP headers and you log it. If you wanna deal with the entity body, like whatever the HTTP body is, then you have to explicitly configure entity interceptors. And the reason that they're being separate is because typically when you are dealing with the entity body, you may be invoking the business logic. You may be doing data binding. You may be invoking a database. So you are making a conscious decision, oh, you know what? This is the entity body on the server side, so let's explicitly configure an entity interceptor in that case. Now the filters and interceptors could work with each other. For example, you could take a look at the filter, and from the filter you take a look at the HTTP header, where it would say, oh, the content is gzipped, and you don't know how to handle the gzip content. Then you could say, you know what? From the filter, pass the control to an entity interceptor, which knows how to ungzip, things like that. So they could definitely work hand in hand in that case to make it a lot more effective. We talked about batch. We talked about JAX-RS. We talked about JMS. We talked about JTA. We talked about JSON. We talked about WebSocket. Any other technology in terms of your preference that you want to talk about?
What is extra?
I know that's always curious, isn't it? That's why I put it. So I wanted to understand how these different NoSQL databases work with Java EE programming model. So what I did is I created a bunch of Maven projects over there. I'm using their native Java drivers, but essentially Mongo, Couch, Redis, React, Cassandra, Space, all of those, I have samples. And if you want to integrate this as part of a Java EE application, how would you do that? Any preferences in terms of the technology?
Concurrency?
Yeah. Okay, we can talk about concurrency. Now, in a Java EE environment, the platform specification says that you cannot spin up new threads because Java EE is a managed environment, and if you spin up your user threads, well, they're user threads. The container does not know about them. And if the container does not know about them, it does not know how to pass the context with it. Security, GenD, class loading, all that context, how will it pass to those user threads? And that has been a problem. Folks have been grumpy about it for the right reason. With concurrency utilities, what we have done is added the ability on how you can create container managed threads. So just the way in Java SE we say executor service, now and create new threads with that. Now we have managed executor service. You can say manage executor service, and using that you can create new threads. Those threads are managed by the container. You don't create the new thread by yourself. You still use the same Java SE design principles, but this time the threads are managed. And by managed, it means the thread actually has the same GenD, class loading, security context as the container has. So you can leverage, you can do your GenD resolution, any classes you want to load, those are loaded appropriately as well. The transaction context is the only one that is not being propagated because doing transaction coordination across threads is not an easy task. That's sort of the thought process over there. So let me show you some code on that.
Quick question. Where does it get its security context from?
From the container. What about the principal in your operating upon?
Right. Okay.
So if you say get principal from in that particular thread, you will get the principal context that the container is running in.
Does it have run as concept?
Say again?
Does it have run as concept?
No.
Okay.
No. The context is whatever context it's running in, that's being propagated to the thread as is exactly. There is there is really no additional functionality here except that making them as a managed threads. That's about it. So in a typical Java SE application, you will say, I want an executor service. You'll create an executor service, and from that you will say, okay, 10 thread pool, and then create a thread, and forward, spin up a new thread, give it to the pool, and execute a job. Here, I'm going to say, oh, I have a managed executor service. I'm going to inject it. And this is the default managed executor service. So this is the default executor service that is available to you as part of the Java EE 7 runtime. Any Java EE 7 compliant server will offer this default executor service. It has to be available as part of that. Once you get a managed executor service, then all of your standard Java SE design principles apply here. I'm saying is, create a new collection of callable. Okay, I create a new collection of callable. I add it to the tasks list over here, and then to the executor I say invoke any. So a bunch of tasks that are available, invoke any task. Not just invoke any, I can say invoke all. Not only just collection callable, I can pass it a collection of runnable. So the way I want you to think is exactly the same Java SE design principle now legally allowed in a Java EE managed environment with all the right context information for you.
And that would pick up the security of the person who just invoked that.
That is correct.
And it would do is user enroll and stuff like that.
Say again?
Would it satisfy things like is user enroll and?
Yes, yes. So you say get principal and all those things, those are available in this case. Yeah. Similarly, the way I showed you manage executor, there is a manage schedule executor. And again, it's very simple, just like Java SE. I'm just injecting a manage schedule executor service here. And when I schedule my tasks, I can call it, I can specify a callable task or a runnable task. And if I say, if I look at the methods that can be called, these are all the standard methods. I'm not adding any new methods to this interface over here. Execute or invoke all or is shut down or schedule, and all of those methods can be called, just like Java SE. Now I can inject it here, which is the default service, but what you can also do is we don't have this sample here. What you can also do is maybe I should add that sample. In WebInf, WebXML, you can specify the JIND name of the executor service. Well, all you do is you give it a JIND name and you provide the service reference, and then instead of using the default executor service, you can actually inject that executor service, which is your specific service. One of the missing features from the concurrency spec right now is how you can configure executor service, your thread pool, all that, the timeout and things like that. That is something that we're going to look at hopefully the next version of the specification. And there's nothing available right now, even in an implementation specific way that can be controlled today. So I think the basic feature is there very much, but how much control is possible? Not very much. Another technology that I would like to talk about is CDI, context and dependency injection. Now this technology was added to the Java EE 6 platform. It's such a fundamental technology that in Java EE 6 you had to explicitly enable CDI by adding a beans.xml. Even if empty, but you need to have a beans.xml. In Java EE 7, it was such a fundamental technology, we said, you know what, we're going to enable it by default. So even if you don't have a beans.xml, we're going to enable CDI for your archive. And let's see how that works. So here I have beans. Well, first of all is beans 1.1 instead of 1.0. This is a beans 1.1 XST, so that indicates the CDI 1.1. Now in this beans element, what we have added is a new attribute called as bean discovery mode. In the bean discovery mode, this particular attribute can take 3 values. All, which says, oh, everything in the archive is available for injection. All the beans in the archive are available for injection. I can also have the attribute value as annotated. What that means is, only the beans annotated with the CDI annotation are available for injection. Or third option being, I could put the value none here, which is a single point turn off, that okay, none of the beans are available for injection. That means CDI is not available in this archive. So those are sort of the 3 values of this attribute by which you can control how the CDI injection need to happen. Another new annotation that has been added to CDI is vetoed. So if you put a vetoed annotation on any bean, that means just that particular bean is not available for injection. You basically vetoed the bean out of CDI layout. In this case, for example, if I were to look at it, I have a greeting interface, simple, public string greet. Then I have a fancy greeting implementation, which implements that interface, and it says hello name. The smiley kind of makes it fancy. And the simple greeting is with vetoed. Now, if I were to deploy this project with no vetoed on it, it would barf and say, hey, what ambiguous dependency cannot be resolved, resolve the dependency, or make it unambiguous, then I can deploy the project. By putting vetoed, it works very well. I mean, there are other ways by which you can do it. You can put a qualifier, mark it as an alternative. There are different ways of doing it, but this way you are explicitly marking it not to be available for injection. Now this is my project in which you can see I have web pages here, but there is no webinif directory in there. If there is no webinif, that means there is no beans.xml. And the fact there is no beans.xml, but still the injection works, kind of shows how you don't need a beans.xml for dependency injection to work. And by default, as I said, the value is annotated. That means each annotation or each bean that you want to be injected must be annotated with a CDI annotation or CDI scope. So for example, if I look at it here, I've just put at request scope annotation. That means this is a request scope bean, but this bean is at least available for injection. Let me show something on bean validation as well. Now here I have this bean. This bean has a method called say hello. All I'm doing is this is the new addition to bean validation by which I could specify a constraint on a method parameter, and this is what we call as programming by contract basically. So all you're saying is instead of in the method saying if name.length is equal to 3, then throw an error back or don't do anything like that, you're just putting the constraint right here in the method parameter. The validator, the bean validation implementation, will automatically validate the constraint, and if it is not valid, it will throw a constraint violation exception. So the precondition and the post-condition as specified by the contract are fully honored in that sense. Here, for example, you're saying show a date. This could be any method like get an appointment date. Well, if you're getting an appointment date, then you're getting an appointment date in the future. The fact that I put add future over there, it always looks for, oh, the date is in the future. It's a raw method. And so it's a show date. I'm passing it a Boolean parameter, say true or false. Do you want a correct date or incorrect date? And then accordingly it throws an exception over here. So the idea is, in this case, if an incorrect date is returned, the method is not even returned back. It throws a constraint violation exception. So whether it's parameters inbound or whether it's return value, which is outbound, in both cases, if the constraints are specified and not honored, constraint violation exception is being thrown. Maybe I'll show one sample of JSF as well. Now, the concept of faces flow or JSF flow has been prevalent for a while. The idea is, let's say you're in a shopping cart. In a shopping cart, you have a place where you're shopping. Once you've done the shopping, then you enter the credit card details, shipping address, so on and so forth. 4 or 5 pages. They are sort of logically related with each other. Apache Faces has this concept of Apache Flow, or Faces Flow, I think, where you can bundle all of those pages together to give it a logical name. It becomes a jar file, which can be shipped across different WAR files, packaged in different WAR files, and then you can leverage it. Oracle ADF also has a similar concept. That's the concept that is being inherited and applied now in a standard way to JSF. So think about as this is at my outside of flow, and again, this is going to be a little bit visual. Okay? So watch yourself for bright colors that show up here. So I'm outside of a flow. If I enter flow 1, it becomes in a flow. I'm in a flow now. In a flow, I have flow scope beam. I have EL expression that tells me whether I'm in a flow or not in a flow. I can click on next, and the next element in the flow is automatically identified. I have flow scope value. So I have flow scope. I can store the values in a flow scope variables basically. So if I click on next, it shows me the value here. From one flow, I can go to another flow. So I'm going to a different flow now. And from that flow, I can even pass parameters. So I'm passing the parameters over there. So this is the first page in flow 2. I can go on next. This is a different flow, so a different flow scope here. So I say foobar 2. I click on next. Foobar 2. I can either go to flow 1 or I can go back to home, and this button, of course, is not working correctly. I can enter back. Oh, goody! Very good. Okay, one demo has to crash at least. Shows it's real. But the idea is, this is sort of the faces flow concept, and that functionality is also added as part of JSF 2.2. Any questions? Well, before I wrap up, as I've been saying, if you have any particular samples that you would like to see, so go to the GitHub repo, see if the sample does not exist. If it does not exist, file an issue that I would like to see this sample. Or if you would like to contribute a sample, Red Hat contributes, it's the open source company, so contribute, send a pull request. Now I have a sample, I have a fix for a sample, here is how I can make your sample better. Contribute a fix. I'm happy to take your pull request, and I will approve the merger, and then we'll go from there. So it's about sharing and it's giving, taking back as well. I guess that's a wrap then. Thank you.
Thank you.